Hello guys, welcome back for another video, and in this one I'm going to talk about binary classification, which is often used in machine learning, and this is the simplest base case for classification, where we must give um, an image or an object, a class between 0 and 1. Okay, so it's just to differentiate two objects, and the idea is to have a classifier that is able to separate the space in two classes, 0, 1, or minus 1, 1, depending on your notation. Okay. So for this example, let's say that we consider this data set with image that represent light and image that represent night. Okay, we have a lot of samples. So class 1 will be light and class 0 will be night. Okay, so we have a lot of those samples. Then the idea is to use a simple model. Can be anything that you want, from CNN to transformer to basic machine learning like models. Then once this model is trained, what we do is can perform for each sample for the test inference, and we can get class for each new sample tested. Okay, so now that we have for each sample tested a new class, what we can do is to evaluate the performance of the classifier. What we do is we construct a confusion matrix. And to construct your confusion matrix, what you need to do is you need to create a 2x2 matrix with the row representing what is actually the class of the object, and the column representing the y-axis representing what is actually predicted. Okay, so there is a full rate that you need to understand, which is first one is the true positive, true negatives. So those two are the correct prediction from the model. False positive and false negative are the wrong prediction from the model. So true positives mean that the class predicted, it was predicted 1 and the object was actually 1. True negatives mean it was predicted 0 and it was actually 0. So for example, for all the class that the object that were predicted 1 and that were actually light, where will be in the true positive case. Then for every true negative, so every night object that were predicted 0 will be in this case. And now all the objects that were actually 0 but predicted 1 will be in the false positive, because they are not positive, they are actually negative, but they were predicted 1. So this is the first mistake that a model can do in a binary case. And also second mistake can be false negative. So it was predicted 0, but in our case it was 1. Okay, so it was light, but the model considered that it was 0. Okay, so typically those two are called TP and TN, for true positive and true negative, and those are the prediction from the model that are correct. Okay, so most of the time you want to have your diagonal with the most value, and the off diagonal with very short value. So it means that your model is good if your diagonal are low value. It means that your model, your binary classifier is not performant enough. Okay, so Fn and Fp, so false positive for Fp, false negative for Fn, are the incorrect prediction from the model. Okay, and typically we call the false positive error type 1 when the model is predicting the model predicted image is light, but in reality the image is night. So it's error type 1, and false negative is error type 2 model predicted image light, but in reality, image is light. For the simple example, it's not big of a deal, not much big of a deal, but for example, if we are in the context of medicine, false positive is model predicted person having cancer, but in reality, the actual person do not have cancer. Okay, so it's can be alarming, but it's not that big of a deal. Okay, so if just say like, yeah, you can have like a stress, can be stressed a bit, but yeah, at the end of the day, you do not have cancer, so it's simple mistake. But the second one, error type 2, which is false negative, is the one that most of the time for critical thing we want to avoid. So model predicted that the person do not have cancer, but in reality the person have cancer. So this type of error is the most is the like error that we want to avoid at any price. Okay, so most of the time we want to minimize this when constructing classifier. Okay. Yeah, so it's basically what I just said, and you need to make sure that when you are building classifier, especially when you have like strong things at stake or important thing at stake, you need to minimize this um, false negative, because this is the thing that will get the most damage for things that are at stake. It can be like money wise or life wise. Okay. So that's it for the explanation. Hope you liked it, guys, and I will be seeing you in another video. If you like those type of content, please like and subscribe, and I will be making more video on how to like explain basic concept on ML, DL, deep learning, and all the AI space, especially for with research. So bye bye, guys. Let's see you in another video.